Hello everyone, and welcome to Introduction to Agent Simulation with CrowdMaster. In this tutorial, I'm going to show you how to give your crowd agents animation and how to make them move around your scene. So, the first thing we're going to want to do is actually get an agent. So, for this example, I'm only going to use one agent, but I'll give her multiple actions. So, let's go and append in this agent that I have right here, Lady 1. And she looks fine now. So the next thing we want to do is bring in some animation. So I'm going to take append, and I am going to append in some of these actions here. And I'm going to use walk 1, 2, and 3. And these are my own files. You can use whatever file you want. So now let's append this in. And if we grab the armature right now, and if we go to the dope sheet and the action editor, if we select one of these actions, you can see there's a bunch of keyframes here. And if we play, you can see she's walking. So, what do we want to do next? Well, the first thing is she's not facing in the positive Y direction. That's not good. So, let's rotate Z 90 and then rotate Z 90 again. Or we could have done rotate Z 180. And if you look at this, it's 180 on the Z and 90 degrees on the X. So we want everything to be zeroed out. We want this to be applied. So the first thing we're going to want to do is make sure that this is a single user object. And then it's Control A. So apply the rotation. And depending on your armature, apply the scale. So that should be fun. Set origin to geometry or not? Yeah, let's not apply the scale. We'll just, technically you should have the scale applied, but for this example, we can leave it at this, which is 0.01. So, now to start generating. So see if there we go. Let's go on to the first layer. I kept everything on the last layer. And let's quickly set up a formation of just an array of these agents. So I'm just going to do a test node tree, and to quickly set this up, I'm going to take advantage of the CrowdMaster utilities. And there's one utility called sample node setups, where we can choose the type of node tree, and in this case we want generation, and choose sample node setups. Now we have a couple of options. So I want a simple formation positioning setup. So I'll click this and hit OK. Now you can see we have a node tree set up for us here. And we can name this whatever it wants. For agent generation, the node trees don't need to be named anything specific. So, a couple tweaks will be necessary here. First of all, this is trying to pull in a single object. We don't want this. We want to pull in the group, the Lady1 group. So, let's connect this, and let's choose Lady1. Also, let's change the template brain type name to Lady1, just to make it easier on ourselves. I think these settings for formation positioning are fine. 25 agents in 5 rows with a margin of 5 in between them all. That'll be fine for this example. But for the size, currently the agent generation nodes treat each object as if their scale was applied, which would mean that all their scale is 1. But in this case, where our scale applies with some errors, we can go to template and random, and usually this would be to set the random value for each agent, and we can still do that. But this, we can use this to set the scale lower than we want, than 1 specifically. So let's just set the random rotation to 0. And because our agent was 0.01 blender units small, we can set that here. And on the max random scale, I'm going to set 0.011, just to add a little variation there. So this should be fine, and what we can do now is hit generate agents and see what happens. And some problems here. Let's see. Let's select, this seems like a mesh object. And what is going on here? Now let's go into the modifiers. Is this armature 1? Yes. Let's try, what's going on here? Want armature. This does not usually happen. Let me see. I have a feeling that this is about our random rotation. So let's select everything, hit apply rotation. And it's giving us errors, so let's select everything, hit L, and make local all, apply rotation, armature, 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 blah, blah, blah. Okay, now let's try this again. There we go. Generate agents, and same error. So in this case, this agent isn't really working for us. So let's select a different one. I'm going to delete this guy, and I'm going to append in a different lady number 2, which should be fine. So let's apply the rotation, and we'll leave this like this for now. Just we can fix this later. So let's go back, and in this case, we're going to want to change the group to lady 2, lady dash 2. There we go, and lady 2. It doesn't really matter. Here, let's hit generate agents and see what we get. Same problem. Now, there are some ways that we could troubleshoot. So let's disconnect this random, see if that has any effect. And it doesn't really look like it. Let's see, what else can we do? Let's delete all these. And do I have any more agents? Man 4. I'm going to try this. Generate. And we're getting... They actually showed up this time. So, I guess we can't apply any of that rotation stuff. So, what we want to do, and that's a bug I'll fix. So, let's just leave that like that and hit generate agents, and everything should probably be fine. But you can see they're lying on their back because we did not apply that random rotation. And now that I'm finding the bug that applying the random, well, just the regular rotation makes them not work, what I'm going to end up doing is, let me just move these to this layer. What I'm going to do is I will take these and I will set a offset on the positioning. So this is a node we haven't gone over before. This allows you to change the location or rotation of each object. So let's add this in right before the formation positioning node. And let's change the rotation offset on the X to -90. And seeing as these are rotated 90 degrees on the X-axis, if we rotate them back -90 degrees, it should make them stand up. Wrong way. Let's set these to +90, and this will add 90 to that. Here we go. Okay, that works fine. So, now that we have our agents, it's time to apply some animation. So currently, if we play through here, you see nothing's happening. The viewport's really slow because these are pretty high poly meshes. And actually looking at this, what we can do, this is going to take a long time. Come on. Darn it. Now looking at this, what we can do is let's just make this margin in between the rows and columns just a bit smaller so we can see these better. Hit generate again, and that's fine. They look like they're almost touching right now, but once we add the animation, they'll be fine. So, let's select this. And now, as you can see, we named our brain type Lady 2 earlier on. We should just name this man now because they're men. Just makes it easier. And the name you set also has an effect on the simulation node tree. So, now that we've generated our agents, let's go into the agent simulation node tree and let's create a new one. Now, seeing as we named the brain type man, we need to name this node tree man. And that's what the brain type is. It's the node tree. So, up here, if we open up our toolbar with T, you can see that a couple things have happened. We have this group name CM all agents under agents. And there's a status unlocked and number, which is the number of agents, and then the origin, which is how the agents were generated, which was automatically by the agent generation node trees. Now, there's this little button here, View Group Details, and we can select this, and this thing here just shows the name of the node tree and the number of agents for each group. We could reset the group, which is deleting all the agents. So, what we want to do now is we want to add the animations for each of these agents. The first thing we did was we entered in or imported the animation clips, the actions. So let's go and add these now. Under the actions panel here, let's click the plus button 3 times because we have 3 actions, and we'll just name these walk 1, walk 2, and walk 3. Now, let's go into these action select dialogues and select walk 1, walk 1, walk 2, walk 2, walk 3, and walk 3. Now, this second row is used for different purposes, but for now, you can just fill them all in because we're just doing this simple right now. So, now that we have this, let's start to get them moving. So the first thing is, this is just going to be the simplest possible. Let's just get them to move in a straight line. And now we won't have anything special like obstacle detection or any of that stuff. Let's just make them walk forward. So the first thing we want to do is add an input node. And this allows you to input all different sorts of values, numbers, strings, all different stuff. Like for example, this is importing a random value. But you can also use this to input path following, all that kind of stuff. So right now I found that a value of 1.1, just a constant value of, 0.1 suffices. And then we want to add an output node. Now, what we want to do is take the output from the input node into the input of the output node. Sorry if that's a little bit confusing. Right now, we want them to walk forward. So that's, if we look at our little cursor here, that's in the negative y direction. So if we do py, that's positive y, and then hit T and hit start simulation, you'll see they're going up. And now, why is that happening? Well, that's because our rotation was not applied. So try to apply your rotation if you can. If not, you're going to have to do all this stuff like this to compensate for that. So in this case, change the positive y to positive z because they're looking at this where they're rotated as the z direction. And let's hit start simulation. Now you can see they're moving along, and we're only going at 4 frames a second, but you can see that they're moving forward just all together. And you know that it works, but you know they're not moving. They're just sort of gliding forwards, and it doesn't look very good. So we want to import these actions. So now that we've created these actions right here, you can see walk 1, 2, and 3. Sorry. We can go in and under state, we can add 3 action nodes here. So the first one we can set as walk 1, the second one walk 2, and the third one walk 3. And because these are looping animations, we want to hit cycle state on all 3 of them. Now you can leave the state length at 1 for all of these because they are looping, but if you have a non-looping animation, you're going to want to set the state length to something other than just 1 frame. So just to demonstrate, let's go into the dope sheet editor and let's select one of these actions. So walk 1, and let's, you know what, let's select our original agent here. Oh, delete. Now let's select our original agent and set walk 1. And how many frames is this? Let's see. This is 30, let's just say 30 frames, just to make it even. So here we can set walk 1 to 30 frames, or 31 if you really want to. Walk 2 is, again, 31 frames, 31. Yeah, let's set them all. Let me just check this. 31, 31, and 26. So let's set that 31, 31, and 26 frames. Now, again, if we go back now, and we hit, let me just make this easier to see, and hit Start Simulation, you can see nothing's happening. And that is because we have not connected these nodes to anything. So, the first thing you always want to do is add this state start. Where is it? Here we go. And this will play one or more of these animations. So, let's hit start, and let's just put it into the first one right now. Hit Start Simulation, and now you can see they're all walking. Maybe not at the perfect speed. You see some gliding there, some sliding. But it works for our purposes right now. Now if we try to replay, I don't know if it's going to be as slow where it's not simulating. It's still pretty slow because these are pretty, they're not too heavy. But anyway, so now it's even just looking a lot better. But if you see, if we connect to multiple actions, they act weirdly because it's trying to play two actions on the same armature at once. So we don't want that. We want to set up a random action. So the way we're going to do this is take our start and let's add 3 inputs. So input 1, input 2, and input 3. And we can leave these on noise.random. So now that we've set this like here, we can plug the start into each of these, and then we can plug the input into the value inputs of each one of these. Now, if we hit Start Simulation, you can see that the agents should, yep, they're playing the actions at different times. And that is good. That's very good. So if we zoom up and go, you can see that their hands are in different positions. So some have some different options here. The next thing we're going to want to do is, this is not perfect. So what we can do is, to make this even more perfect, is change this noise.random to use a function that is built into CrowdMaster, which is multi-agent random. So what this does is it applies a random value to each of the agents and then keeps it throughout the simulation. So let's do this right here. Multi-agent random right here. Noise, multi-agent random. And we're setting 0 because this is the first action. So let's hit enter, and we'll copy this, and we'll put this in here, and we'll change 0 to 1. And then we'll add this in here and change 0 to 2 because coders start with 2. So now, if we go back to the start and hit Start Simulation, you will see that the simulation is running. So, we see the agents walking, and if we stop again, you'll see they each have a different action here. So obviously, we only have 3 actions here, so it's not too descriptive, but you can see the difference in between 3. So if you had more than 3, it'd probably look a lot better, because we have 25 agents. So technically, we should have at least 25 different actions, because then they would be following that. But for this example, 3 is fine. So really, that's the main part of getting these agents up and walking. And this, again, we used formation positioning for this example, but you could use any positioning at all. Currently, like I said, this is the simplest form. This is just saying move a value of 0.1 along the local forward axis for each one of these agents. So, if you were doing some sort of like a random positioning where they were rotated at different angles or whatever, they would be walking through each other. But if you're doing a background crowd or something and you just need something really quick, this works. Later on, I'm going to show you how to do more complex positioning and moving and everything and flocking and all that stuff. But for now, this should do the trick.